I'm going to go through the 6 different trig parent functions that you should know. So first, y equals sine of x. You should know that it starts on its midline, and then it will go up by its amplitude, down by its amplitude, down by its amplitude, and up by its amplitude over a period of 2 pi. So the period of this graph, you should know is 2 pi. And then the same thing for y equals cosine x, except for instead of starting on the midline, it starts above the midline, and it goes down by its amplitude, up and up. It looks something like this. So what we learned new recently was these other 2 graphs called cosecant and secant. And the way that we built them is we realized that to graph cosecant, we could first graph sine, and that'll help us build cosecant. So I'm going to sketch the sine curve first here, and I'll do it with dotted lines. And what we learned is that where the sine graph that I made here crosses the midline, that's where we're going to get our asymptotes for cosecant. So here's one asymptote, here's another, and here would be a third. And then from there, if we just drew some u's, which aren't parabolas, but they look like them, off of the maxes and mins, tending towards the asymptotes and away from the sine curve, that'll give us our cosecant curve. So that would be, again, a period of 2 pi because it has the same period as sine does. The way you build secant is the same way we build cosine. So we're going to start making our dots and make a little dashed line here. So now the asymptotes for secant's parent function are at pi over 2 and 3 pi over 2. And so we get a u right here. And then we get sort of half u's. Here's a half u, and here's a half u. So if we continued the graph, we'd get complete u's, and there'd be more asymptotes. But that's what secant of x would look like. Now for tangent and cotangent, these graphs are a little bit more complicated. So here are some things you should know about tangent. What tangent starts with is on its midline. So here's a point on its midline. And what tangent tends to do is it goes upward. But before I do that, I want to talk about the period of tangent. So for all these graphs over here, they all have a period that equals 2 pi by default for all 4 of these graphs. For tangent, I'll draw a line right here, its default period is pi. So that means starting from this point, if we were to move pi away from there, we would find that exact same point again. And if we moved pi away again, we'd find another point. Another thing we discovered about tangent is that the asymptotes are in between those middle points. So for tangent, we're going to have asymptotes here at pi over 2 and 3 pi over 2. Then if we want to be really fancy with this, the amplitude of tangent we don't say exists. There's not really an amplitude, but there is an a value here, a 1. And what that tells us is that how much the graph is stretched. So if we went in between this middle point of the asymptote, we're going to get a point right about here, up 1. And our graph will go up like this. Same way over here, if we went over halfway between the middle point and the asymptote line. If we go up by 1, we'll get this point. If we went down by 1, we'll get that point. And likewise, we'll have this point right here. We'll get the tangent graph. Cotangent works the exact same way except for 2 small changes. The first is instead of starting with a point, cotangent starts with an asymptote. So there's an asymptote. We know that the period is pi, so if I go pi away, I have another asymptote, and pi away again, another asymptote. Now, we now know that between the asymptotes we should have those middle points that are on the midline. And we know that cotangent goes downward. It's a decreasing function. So I'll do the exact same thing I did for tangent, except for now the graph is going to tend in the downward direction. So it's going to be important for you to know these different parent functions because you're going to be asked questions about writing the equations of them. You're going to be asked questions about making the graphs, when there's going to be transformations. But first you have to know what the parent functions look like to be able to do that. Some other quick things that I want to review in this picture about parent functions. Let's talk about domain and asymptotes. So for like cosecant here, we would say the domain would be all real numbers except, and what we're going to throw out are everywhere there's an asymptote. So the way to do that is to pick one location of an asymptote, so here's 0, and then add to it the distance to the next asymptote, which in this case is the distance of pi. So we would say the domain of this function is all real numbers except 0 plus pi k, which you may note you don't need the 0 plus. So if you just wrote all real numbers except pi k, that would mean the same thing. Let's do the range of secant. So this graph does not go anywhere in the middle section for the y values. There are only going to be y values that are in the bottom section from -infinity to -1, combined with, or unioned, with all the values from 1 to infinity. It is important, as I almost made a mistake there, that the numbers have square brackets to say inclusion, that we reach those values, and then the infinities have parentheses. It also matters the order here, that it goes from -infinity to -1. And if you flip-flop those, it will not be correct. It always go from smallest to biggest. Now let's do the same thing for tangent, but let's write down where the asymptotes are. So the way that we're going to record the asymptotes is we're going to say they're all in the form x equals, because they're equations of lines, one of the asymptotes, which is pi over 2, and then the distance to the next asymptote is pi over y. So that would be the equation of all the different asymptotes. So this is a quick summary of what you should know in terms of the parent functions for sine, cosine, cosecant, secant, and tangent, cotangent.